Hi everyone, today I'm going to talk about parent functions. Our essential question is what is a parent function and what makes each one unique? A parent function is basically the simplest form of a function. First, let's learn about linear function. The general form of the equation of linear function is y equal to x. So I'm going to use this equation and all these x values to find the y values for them and then graph the function. So if this is my equation, y equal to x, that means all the y values are going to simply be equal to y. If x is -2, y is also -2, -1, -1, 0, 1, and 2. So they're just simply equal to each other. Now I'm going to find the points 0 and 0, 1 and 1, 2 and 2, -1 and -1, -2 and -2. Now I can graph the function by connecting these lines together. So this will be the graph of this function. It's a solid line, straight line that passes through the origin. To find the domain and range of this function, I just need to move from to find domain and look for the x values. So as I move from left to right, just also consider that there are arrows at two ends of this graph. That means that they are continuing from both sides. The points are continuing from both sides. So to find the x values, I move from left to right and I see that all the x values on the x-axis are being covered by this graph. Like for any x value, there's a point on my graph like this. Any x has a y defined for that. This one and anything else, like all the points are covered. That means the domain is all real numbers from negative infinity to infinity. So from the left side, which is negative infinity starting and then continues to positive infinity. We use interval notation to write our domain and range, and that's how we do that. So for infinity, we always use parentheses. Then for range, I have to move bottom to top and look for the y values. So as I start from the bottom, I see that again for all the y values, we can find a point on graph that has an x defined. So that means all the y values are also covered here and we don't have any restriction or any holes here. So range again is negative infinity to infinity. If you look at this graph, we can have a rotational symmetry of 180. That means if I rotate this graph for 180 degrees, it's going to match on the original graph. So that means it has a rotational symmetry of 180. Here I have made some little thing for you. This combination of a graph and word is a trick that helps you remember that a linear function is always like a solid and straight line. So I use the letter L to change it in this way. So this is a little trick to help you remember the shape of the graph. Next, we have absolute value function. The general form of the equation is y equal to bar x bar. So we call that absolute value function. What does this do? If you have, let's say, a value -2, and you give it to the function of y equal to absolute value of x, it's going to change it to 2. Basically, takes the negative and makes it positive. -1 will be 1. 0 is going to be itself. 1 itself. 2 itself. So only if we give the absolute value function a negative value, it's going to take the negative and change it to positive. If you want to use your calculator to find the values, I'm going to show that to you right now. So to use your calculator, as I've listed here, you're going to use alpha, window, and then choose one absolute value. This is how it works. Alpha, window, and you're going to see the list of all the functions. The first one is absolute value. So you choose number 1, and then it's going to give this to you. Let me give it -3, for example. The answer is 3. Once again, alpha, window, and number 1. This time I'm going to give it 3, and it's again 3. So that's how we use our calculator for that. Okay, now I'm ready to graph the function 0 and 0, 1 and 1, -1 and 1, 2 and 2, and -2 and 2. So the graph can look like this. One line from here to here, and the other one here. And we have arrows on the end sides. So as you notice, the graph looks like a big V form. I have also made this for you to help you remember that absolute value function is like a big V. So the V letter can represent the shape of the graph. Okay, domain and range. So for domain, I'm going to move from left to right, x values. As I'm moving from left to right, I see that all the values of x are defined here. There's no restriction and no hole here. So everything is covered, and the graph is going to continue from left and right. That means it's from negative infinity to infinity. Range, I move from bottom to top, and I see that the negative y values are not being covered. There's nothing defined on the graph for negative y values, but my function is starting from 0, and this 0 is included to function. So it's going to start from 0, and then since everything else is covered and we have arrows here, it's going to continue to infinity. Because 0 is included, I have used a bracket here, but we know that infinity always has only parentheses. What kind of symmetry do we see? If you notice, we will see that there is a symmetry at the y-axis. This is my y-axis, and the right side and the left side of that are mirror of each other. That's why we say this is reflectional symmetry at y-axis. Okay, so reflectional symmetry at y-axis. Now let's go to next one, quadratic function. Equation of quadratic function is y equal to x squared. Okay, so we're going to try some points on this function. If I give -2 to the function of y equal to x squared, it's going to be -2 to the power of 2. I put in the -2 in parentheses because I want to show something to you. I'm going to show it on calculator. So if I write, we know that -2 to the power of 2 is -2 times -2, and then -2 times negative is positive, 2 times 2 is 4. So the answer should be 4, okay? If I don't put parentheses when I'm using my calculator, this is what I'm going to get. -2 to the power of 2, okay? It's going to give me -4, which is wrong, because -2 squared should be equal to 4. But if I use a parenthesis, then put -2 to the power of 2, then the calculator is going to give me the right answer. So notice, whenever you're using calculator, even when you're writing on your own on your paper, make sure you put parentheses around -2. Say that you are raising -2 to the power of 2, not only the 2. Okay, so this is equal to 4. Then -1 to the power of 2 will be 1. Again, we have the same story. We need to put that in parentheses. Then 0 squared is 0, 1 squared is 1, and 2 squared is 2. We don't really have to put parentheses for this positive number. Okay, so the values 0 and 0, 1 and 1, -1 and 1, 2 and 4. It's going to be somewhere like here, negative 2 and 4 here. Now I can graph the function, and this will be the graph of this function. It looks like a big U, and we have arrows on the inside. We also call this graph as a parabola. The other name is a parabola. Okay, now let's find the domain and range. For domain, I move from left to right. And because I see that there's an arrow on two sides, that means it's continuing to increase from right side and go to the left side. And so all the x values are being covered by this graph. We don't have any restriction. So from negative infinity to positive infinity, all the x values are covered. The same for the range. I'm going to move from bottom to top this time. So as I move from bottom, I see that the y values, which are negative, are not being covered. And the graph is starting from 0. And this 0 is included to my graph. So I'm going to write bracket 0, and then it's going to continue increasing to the top. So to infinity. We see a reflectional symmetry at y at the y-axis, because the left and right side of this graph are image of each other, or mirror of each other. And here's a little trick for you to remember that quadratic function is like a big U-form thing. Next, we have a square root function. Square root is the inverse of square function. And this is the equation, y equal to square root of x, or radical x. So I'm going to give some values to this function. If I give negative 1 to x, let me show this to you what happens. I'm going to use calculator and give negative 1 to this, and we are going to get error, non-real answers. We know that on the radical we can never have a negative number, so for negative 1, basically my function is undefined. It's not defined for negative values. If I give 0, square root of 0 is itself. Square root of 1 is 1. Square root of 4 is 2, because 2 to the power of 2 is 4. 1 to the power of 2 is 1. And then square root of 9 is 3. 3 to the power of 2 is 9. So now I can graph the function 0 and 0, 1 and 1, and then 4 and 2, and so on. So I can graph the function in this way. So domain of the function, as I move from left to right, I see that I don't see anything on the left side of the x-axis. The negative x's are not covered. So start from 0, bracket, and goes to infinity. From the right side, all the x values are covered. For range, I move bottom to top, and negative y's are not covered. Starts from 0. 0 itself is included, so I put bracket, and then it's going to continue cover all the positive values. So to infinity. We don't see any symmetry here. And this is a little trick for you to remember the graph of square root function. Just use the R and use it this way. That means it's going to continue to the right side. Next, we have cubic function. Cubic function has this equation, y equal to x to 3. So I'm going to replace these values to this function. Negative 2 to the power of 3 will be negative 8. I'm going to show you why this happens. Negative 2 to the power of 3 is negative 2 multiplied by itself for 3 times. 2 times 2 times 2 is 8. And then how about the signs? Negative times negative is positive. And then this positive times this negative will give us a negative value. So it's negative. You can also use your calculator to find that. I'm going to show that here to you. Okay, again, I use a parenthesis, -2 to the power of 3, and that gives me -8. -1 to the power of 3 will be -1. 0 to the 3, 0. 1 to the 3, 1. And 2 cubed is 8. So the values are 0, the points are 0, 0, 1 and 1, 2 and 8. Let's say it's some point like up here, 2 and 8, -1 and -1, -2 and -8. Again, let's say it's a point like here. Now I'm going to connect these together, and this will be the graph of my function. I put arrows here to show that it's going to continue from both sides. Now, what is my domain? As I move from left to right, I see that because this graph is going to continue to left and the bottom, it will eventually cover all the x values, and there is no restriction, no hole, nothing. So it's going to continue, and to the right side again, it's going to go top and the right. So again, to infinity. That's the domain. And now we're going to talk about the range. I move from bottom to top, look for the y values, and it's covering everything from bottom to top. Everything is covered, so it's -infinity to infinity. We have a rotational symmetry of 180. That means if I rotate this graph for 180 degrees, it's going to match the original. So I'm going to show that to you. So I'm going to rotate this for 180 degrees, and it will match the original one. Well, of course, my graph is not really perfect, but it should match itself. Okay, now, and here is just a little trick for you to remember the shape of cube function. Just use the U and graph this little thing on that. That will help you remember the graph. Cube root function is the third root of x, and we can use this equation for that. So I'm going to use my calculator for this. Y equal to cube root of x. I use the bottom math and 4. Let me show that to you. So I go here, math, and number 4 is cube root. So I choose cube root, and then I can write, let's say, -8 gives me -2. Because -2 to the power of 3 was -8. Now, cube root of -8 is -2. And let's try that again. This time, cube root of 8, it's 2. Cube root of 1 is 1. And cube root of -1 is -1. So this is -2, -1, 0 is 0, 1, and 8. The points will be 0, 0, 1 and 1, -1 and -1, and 8 and 2 is going to be, let's say, somewhere like here, -8 and -2, again, something like this. So this will be the graph of this function. Now, we know that if we rotate this function for 180 degrees, it's going to match the original one. So that has a rotational symmetry of 180. And here's again another little trick for you to remember the graph of the function. Then we have constant function. Constant function has this equation, y equal to c. And this c is just a constant value, constant number like 1, 2, 100, -50, whatever you choose. And here we have an example, y equal to 2. The equation says no matter what is your x, your y is always going to be equal to 2. So if your x is 0, 1, -2, whatever, your y is always 2. That makes the graph of this function look like a straight horizontal line that passes through y equal to 2. Remember, HOY is that H stands for horizontal, O stands for zero slope, and Y stands for Y is equal. So this is exactly the same thing that we talked about before. It's a horizontal line with slope of 0. What kind of symmetry do we see? We have a rotational symmetry of 180 because if we rotate this for 180 degrees, it's going to match the original one. And also we have a reflectional symmetry at the y-axis. That means if I consider this y-axis, the right and the left side are mirror of each other. And here's a little trick here. Constant, I use the T letter and change it in this way to show you that the y equal to c is always a horizontal line. Rational function. Let's talk about rational function. Now y equal to 1 over x is the equation. Now I'm going to use some points, give to this function, and see what happens. So if I give -2 to the function, it will be y will be -1 over 2, or let's say -0.5. I give 1, it will be -1 over 1, which is 1. 0, it will be 1 over 0, which is undefined. If you use your calculator, you're going to get an error for this because we can never divide a number by 0. That's undefined. 1 divided by 1 will be itself. 1 divided by 2 will be 0.5. I'm going to try some other numbers in between 0 and 1, see what happens. So this time I'm going to use -1 over 2. And here I'm going to use 1 over 2 and see what happens. I'm going to use my calculator to find the answer. So this will be basically 1 divided by 1 over 2. So let's see what is that equal to. Alpha y equal, and number 1 gives me a fraction. So on top we have 1, and on the bottom I'm going to make another fraction, alpha y equal 1. So this time it's 1 over 2. Or I can change it to -1 because we were working on -1, -1 over 2. And here's the answer, it's equal to -2. Next I'm going to use the other number, 1 over 2. So second y 1, so to make a fraction I go here 1, and the bottom again alpha and y equal to 1, and this will be 1 divided by 2, and the answer is 2. So if I give 1 over 2, I'm going to get 2 for that. Okay, now we're going to start graphing these numbers. So if it's -2, if x is -2, y is -0.5. So it's going to be somewhere like, oh, I'm sorry, this is 3. -2 is going to be here, 0.5, -0.5. -1, it's going to be -1. This was negative. And if I give -1 over 2, the answer will be -2. So it's going to be here. Then on the other side, if I have 1 over 2, the answer is 2. If I have 1, answer is 1. If I have 2, answer is 0.5. So the graph will look like this. 2 different curves, one on the top and right, the other one on the left and the bottom. So this will be the graph of a rational function. Okay, now let's find the domain and range of this function. For domain, I have to move from bottom to top. I'm sorry, I have to move from left to right. So I see that I'm covering all the x values here. Everything is covered from negative infinity. But as I reach to 0, there's nothing defined for 0. 0 is undefined. So I have to make a jump here and then go after 0 and continue from that point. So I'm going to write 0, close parenthesis, jump, and open parenthesis, 0. That's the next step. And then continue to infinity. That will be the domain. For range, I move bottom to top and look for y values. Again, the negative y values are covered. Everything is covered from negative infinity. As I reach to 0, this is not defined. For 0, it's not defined. So I have to make a jump and start from after 0, and then it's going to continue to infinity. So this will be the range. We have a rotational symmetry of 180. If we rotate this for 180 degrees, it's going to match the original function. Okay, so I'm going to rotate this for 180 degrees and see what happens. So here's my graph, and I'm going to rotate this for 180 degrees. And we see that it's going to match the original. So we have a rotational symmetry of 180 here. And here's the little trick. Use the letter T, and I draw the little curves on two sides. That will help you remember rotational function. I'm not sure if I talked about domain and range of constant function. So for domain, I move from left to right, and I see that all the x values are covered. For any x, we have a point on the graph. For all the x values, we have the y value equal to 2. So it's negative infinity to infinity. Everything covered. But for the range, as I move from bottom to top, I see that nothing is defined unless the value of y equal to 2. Only 2 is defined. So I say the range is only value of 2. Exponential function, the equation looks like y equal to b to the power of x. And this value of b should be always greater than 1. Why? Because let's try that. If I have, instead of b, I put 1 to the power of x. No matter what is my x, 1 to the power of anything is always equal to 1. So this equation will look like y equal to 1, and that's basically the constant function. So it's not going to be exponential. That's why we need this to be greater than 1. Never can be equal to 1, and it can't also be 0. Again, 0 to the power of anything is 0, and it doesn't also accept negative values. So only greater than 1. Okay, now I'm going to give different values to x. Notice that here I said the b value, like the base, should be always greater than 1, but the x can be anything. I give -2, -1, and so on. So, okay, I'm going to try my calculator. The base, I use base 2 here. Okay, base is 2. So for the first one, y equal to the power of x, it will be 2 to the power of -2. Then 2 to the power of -1. 2 to 0, 2 to 1, and 2 to 2. What is 2 to the power of -2? It's 0.25. Then 2 to the power of -1. It's 0.5. 2 to the power of 0 is always 1. Anything to the power of 0 is always 1. So this was 0.25. This is 0.5. This is 1. 2 to the 1 is 2. And 2 to the 2 is 4. Okay, so let's try. If x is -2, y is 0.25. So it's going to be somewhere like here. -1 is 0.5. 0 is 1. 1 is 2. And for 2, it's 4, somewhere like here maybe. So I can connect the points and it's going to go here. So as you see from the right side, the graph is just increasing, going to top and the right. And from the left side, this graph is getting close to 0, but never passes because the y value is never going to be a negative value. That means we have an asymptote here. We call that horizontal asymptote, and it's called y equal to 0. The equation for horizontal asymptote is y equal to 0. So the graph gets close to 0 but doesn't pass. The range of this function, as I move from left to right, all the x values are covered. You see, for any x that you consider, there is a point defined on the graph. So it's going to be -infinity to infinity. But range is not covering the negative values. As I move from bottom to top, the negative values are not covered, and the 0 itself is also not covered. And the graph is going to start from a point right after 0. Because 0 itself is not covered, the y value of 0 is not covered, so I put a parenthesis here. And then continue going to infinity. So that's range. We don't have any symmetry here. And here's the little trick to remember. Use the L in this form to remember this is exponential function. Then we have log function. Log function has this equation. Y equal to log of x. Basically, we have a base here. This base could be any number, again, greater than 1, but in this case, we have considered that b is value 10. And if we have 10, we don't have to write that. So I just don't need to write anything here. We're going to talk more about log function in future, but here we are just going to talk about the graph. Okay, so I'm going to try these values to find y equal to log of x. Okay, so I'm going to use my calculator to find log of -1. I'm going to try this log of -1. We get an error. That means for -1, log is not defined. And then try 0. Log of 0. Again, we have an error here. For 0, it's not defined. Now I'm going to try log of 1. It's 0. Log of 5 is 0.69 something, and log of 10 is 1. So this is 0, this was 0.69, and this one was 1. So when x is 1, it's 0. When x is 5, let's say this is 1, this is 5, and this is 10. So I just made the numbers here to make my graph. And for 5 is 0.69, and for 10 it's 1. Let's move the 0.69 somewhere like here, and for 10 it's 1. So I want to try one more number to get something here to understand what is happening at this point. Let's try 1/2 here. Between 0 and 1, 1/2. So I'm going to go to my calculator, log of 1 divided by 2, close parenthesis. It's -0.3. So it's -0.3. That means if x is something less than 1, between 0 and 1, like 1/2, the y value is a negative number. It's going to go here. So I can continue my graph and this way graph it like this. From the right side, the graph is going to go to top and the right, and from the left side, it's going to get closer and closer to 0, and it will never pass this point. Never pass 0. So we have a vertical asymptote at this point, and the vertical asymptote is x equal to 0. To find the domain, I see that my graph is going to uncover the negative x values and then starts from after 0. The 0 itself is not defined. As you see, if we give 0 to x, we're going to get error. And also for negative values, we get error. That means negatives and 0 is not covered. So it starts from after 0. That's why I put parentheses and then goes to infinity. For range, I move from bottom to top. It's covering all the y values, and it's going to continue from both sides. So it's negative infinity to infinity. And there is no symmetry here. And the last is the little trick. I use the log, the L, in this form to help you remember the form of the graph. And this was today's lesson about parent functions. Have a good day.